Only use L'Hopital's rule, guys, if we get this. If you get infinity over infinity, or the other one is 0 over 0, you have to have an indeterminate form. Indeterminate form. If you have an indeterminate form, then you can use L'Hopital's rule. What is L'Hopital's rule? L'Hopital's rule is just taking the derivative of the numerator and the denominator and then finding the limit again. Okay, so let's take a look at this guy. If I plug in infinity to the top, like if this function is getting bigger and bigger and bigger, what would this guy be approaching? Let's see, let's think about that for a second. We know that the function natural log looks like this. Okay, so you can see that as the x value goes closer and closer to infinity, this guy right here is also approaching infinity. He's approaching infinity really slowly, but he is. He's continuing to go up as he's going out to the right. So we have infinity raised to the third power, which is just another infinity. So we have infinity up top. On the bottom, we have the same situation. We have natural log. Yeah, now we're multiplying the x times 4. That's just going to stretch this function out a little bit, but we're going to get the same behavior. We have infinity over infinity, so we can use L'Hopital's rule on this guy. So after L'Hopital's rule, this is what we would have. The limit as x approaches infinity. So we got to take the derivative of the top and the derivative of the bottom. When I take the derivative of the top, I get 3 natural log of x times 1 over x. How'd you get that? Well, I have natural log of x inside the function that's to the third power. And so I have to take the derivative of the third power first. Oh, I almost forgot. Should be a second right there. So I drop the 3, multiply it times the natural log of x, and then I take 1 away from the 3 to get the 2. And then I have to multiply it by the derivative of natural log, which is 1 over x. When I do the other one, I take the derivative of the natural log first, and so it would be 1 over 4x. Then I multiply that times the derivative of 4x, which is 4. And let's simplify before we do the limit, actually. So we could say this is equal to the limit as x approaches infinity. On the top, we have, ooh, nastiness. We have 3 natural log of x raised to the second power divided by x. On the bottom, these 4's are going to cancel out. We have 1 over x. And so actually, I can multiply the top and the bottom by x, which is the same as multiplying the whole fraction by 1. And that would cancel out this x, and that would cancel out that x. So actually, we could simplify this even more. The limit as x approaches infinity is of 3 natural log of x raised to the second power equals what? Okay, now this isn't a very satisfying answer because we kind of have the same scenario as before. We have a natural log function right here, and we know what a natural log function looks like. It looks like this. And if we go to infinity, we take x to infinity, this function continues to go to the right and up, which means we're approaching infinity on our y-axis. So this is getting continually big. Squaring it and multiplying by 3 is just going to make it continually even bigger. And so we're just approaching infinity on this. Okay, so our answer for this one is infinity.